Yeah, good afternoon, student. Welcome back to probability theory and stochastic process class. In the last class, we are going to discuss about discussed about the different definitions of probability theory and then axioms of probability theory and some of the laws, and then we also discuss about the set theory, basics of the set theory, and also we are discussed about the something called joint probability and then conditional probability. And then different types of events. What are the different types of events of a probability? Like mutually exclusive events, statistical independent events. So these are the basics we are seeing in the last class. And mainly today we are going to discuss about the total probability theory and what is the importance of total probability theory, and then how we are going to derive that particular theory of the total probability. Okay. So before going to that, we have to know what is the main application of the total probability. Why we have to study the total probability. Okay. So in the theory of probability, as we discussed in the previous class, we are talking about the conditional probability and then marginal probability. What is meant by conditional probability? That is, the occurrence of event A is depend upon the occurrence of the other event. It may be either B or any other event. That is, the occurrence of one event is depends upon the occurrence of the other event. Then what about marginal event? The marginal event is nothing but the occurrence of one event does not depends upon the occurrence of the other event, right? Similarly, we have a joint probability, and then we have a something called statistical independent event or mutually exclusive events. From the property of joint probability, what is the formula of joint probability? Probability of A union B equals to, that is, union of A and B equals to probability of A plus probability of B minus probability of A intersection B. Okay, but when the two events are statistically independent, and what is the condition of probability of A intersection B? When the two events are statistically independent, probability of A intersection B equal to multiplication of the marginal probability of the particular events, that is probability of A into probability of B. And similarly, if the two events are mutually exclusive events, that is probability of A intersection B equals to 0, that is nothing but empty set, right? So the marginal probability is calculated when the events in a sample space are independent of each other. But when the two events are dependent on each other, that time we are going to calculate the conditional probability. Okay. And then based on these two conditions, it's starting conditional probability and then marginal probability, we are going to define or we are going to derive the theory of the total probability. The aim of the main application of this total probability theory is mainly used for derive the Bayes theorem. And then what is the application of Bayes theorem? In the all real-time applications, like in today's deep learning or computer vision or any advanced technology, for prediction purpose, for prediction of the probability of the occurrence of an event, that is that prediction of an event, to uh, get the prediction of a particular event of the future, we have to go with the Bayes theorem. Okay, that is one of the main application of the Bayes theorem. So to derive the Bayes theorem, we have to know the total probability. That is, Bayes theorem is derived from the total probability, and then these total probabilities depends upon the conditional probability and then marginal probability, and also we have a something called multiplication theorem of the probability. So using these three conditions and one more, and it also depends upon the mutually exclusive events. Okay, and also we have to know the basic knowledge about what what is sample set, what is an event, okay, what is a mutually exclusive event, what is an independent, what is joint probability, what is conditional probability. So these are the basic things we have to know before only to solve the or to study about the total probability theory. Okay, next, so we'll see what is the conditional probability. So as we said, what is the conditional probability? the occurrence of event A is depends upon the occurrence of another event B, right? So let's go with the, this is event A, probability of A, and this is event B, probability of B. And the joint probability, what till now we discussed about the joint probability, right? The intersection of two events A and B is called as a joint probability, that is probability of A intersection B. And then how we are going to calculate the conditional probability? That is occurrence of A is given by occurrence of B. That is B is the prior probability and A is the posterior probability. So that is the thing, but probability of A given by B is the posterior probability. Here the probability of B is the prior probabilities. That is the thing, but the conditional probability is defined as probability of A given by B equals to probability of A intersection B by probability of B. Here the probability of B is the marginal probability of an event B. Here the probability of A given B equal to the conditional probability of an event A. And then, as we know, probability of A intersection B is the joint probability. So as we discussed, the probability of A given B, the proportion of A and B is B. So next we have to know about the multiplication rule. So this is the one another important consequence of conditional probability is the multiplication rule. That is nothing but the joint probability can be calculated using the conditional probability. That is probability of A intersection B equal to probability of A given B by into probability of B. So how we are going to get this? As we know, conditional probability, probability of A given B equal to what we know? Probability of A intersection B by probability of B, right? So if you want to get this probability of B, what we have to do? We have to take this probability of B into left side. Then what you are going to get? Probability of A given by B into probability of B. So this is about the multiplication rule. So it depends upon based on these two, that is conditional probability and a multiplication rule, we have to derive the total probability. And then also I discussed about the statistical independent. What is statistical? When the two events are statistical independent, that is event A is independent of B, then the probability of A is not affected by the probability of B. Similarly, if you want to go with probability of B by A, probability of B is not depends upon the probability of A. That is nothing but, so when the two events are statistically independent, then the conditional probability becomes the marginal probability of that particular event. That is nothing but the occurrence of A given by B is equal to the probability of event A only. Similarly, the probability of occurrence of B given by A equal to the probability of B. Similarly, as I said, the probability of A intersection B equal to probability of A into probability of B. Okay, students. Now we have to go with our today's topic, that is the law of total probability. Okay, so why we have to go with the total probability theory and what is the importance of this total probability? The main application of this total probability is to derive the Bayes theorem, and the Bayes theorem will use for the prediction of an event. So this is very much useful in this today's deep learning algorithms. That is, suppose we have a sample space. Let us take, we have a sample space yes. This is total sample space yes. In this sample space, let us consider n disjoint events. Here the event B is consisting of n number of events. That is B1, B2. Let us take this is B1, and this is, let us take this is B2, and this is B3, B4. Let us take this is B5. Similarly, let us take B6, B7, B8 up to Bn. These are the n disjoint events. That is, the in these n events, any two events are mutually exclusive events. That is, the intersection between any two events are zero. And then So from this, the sample space divided into n independent events, right? Okay. Now from these n independent events, how we can define the sample space? So sample space S is equal to, what should I write? Summation of B1 plus B2 plus B3 so on up to Bn. So this is also written as union of n equal to 1 to union of n equal to 1 to capital N into Bn, right? So that's why it is written here, E is written omega, right? So that is nothing but sample space. Okay. Let us consider another event A. Let us take another event A occurred depends upon the all the events of the n events. That is, A is depends upon the event B. Here, how many number of events are there in the B? In B, we have a n number of events. So let us take the event is given by B1, or the event A is given by B2, or event A is given by B3, so on up to the event may be occurred depends upon the B1, B2, B3 or Bn, right? So if you want to calculate the occurrence of event given by B1, so what is the formula? So from the conditional probability, what you can write? So from the property of conditional probability, probability of A given B1 equals to probability of A intersection B1 by probability of B1. Similarly, if you want to go with the occurrence of event A with respect to B2, then what is the probability of occurrence event A? Probability of A given B2 equals to probability of A intersection B2 by probability of B2. So like this, we have to go with n number of events. So finally, so how we are going to write the total probability? The occurrence of the total probability event A equals to the occurrence of event given by B1 plus the occurrence of event A given by B2, similarly so on up to the occurrence of event A given by Bn. So summation of all this is becomes what? What we can write? That is summation I equal to 1 to n probability of A given Bn into what we can write. So let us take, that is B1 intersection A, and this is B2 intersection A, B3 intersection A, intersection A, like this. Okay. So as we discussed, the probability of an arbitrary event A in sample space can be written as probability of A equal to probability of B1 intersection A plus probability of B2 intersection A plus probability of B3 intersection A plus so on probability of BM intersection A or BN intersection A, right? So from this, how we can, from the property of conditional probability, what is the A probability of A intersection B? Probability of A intersection B equal to probability, or sorry, multiplication theorem. From the multiplication theorem, probability of A intersection B equal to probability of A given by B into probability of B. So similarly here, probability of B1 intersection A equal to what should I write? Probability of A event given B1 into probability of B1. Similarly for n events you can write, and then addition of all those things is become a total probability of an event here, right? So this is also written as summation of I equal to 1 to n probability of A given Bi into probability of Bi. This is nothing but total probability. Okay. So the law of total probability, finally what is the result? Probability of A equals to summation I equal to 1 to n or n to m probability of A given Bi into probability of Bi. So this is it is very important, and this is the basic to go with the Bayes theorem. Okay. So in the next class we are going to discuss about the Bayes theorem. So with this I am going to end the session today. Thank you, and if you have any doubts, please ask me. Thank you students.